We are going to see now the vertical circular motion. There are two types of vertical circular motion. One type is vertical circular motion that is controlled by the gravity. In this case, that motion is controlled by the gravity. The example is the giant wheel. Here, the speed of the vehicle, that means that remains constant, either remains constant, it can be controlled, and therefore we can say that it is controlled by the gravity. And another type of vertical circular motion is the vertical circular motion that is depend upon the gravity. Here, in this case, a small energy is necessary at the lowest position, and during entire motion or during entire kinetics, that is governed by the gravitational force. In that case, the or gravitational potential energy, there will be the interconversion between gravitational potential energy and the change in kinetic energy. First case we are going to say now, if what happens, if an object, small object or point object having mass m, that is tied to a string, and that string is massless, flexible and inextensible string. If that object is tied to such type of string and filled in a vertical circle, then you can find that the bob performs, or the point mass performs the vertical circle and moves along the vertical circle. It performs the vertical circular motion, and the string, it undergoes in a vertical plane. With the help of diagram, we now see how the vertical circular motion will take place if a bob having mass m, that is tied to a string. Here, in this case, this is the uppermost point A, this is the lowermost point, and these are the fixed positions. You can say it will be equal to, suppose it will be C, this is your A, B. Here you can say this is point C and here it is point D. Now here at point A, here the forces acting, it will be equal to mg, that acts in the downward direction, and here tension, that will also be equal to T, and that will be equal to TA. See here, at any position of the bob, there are two forces acting on the bob. First will be its weight mg, that acts in the downward direction, or its weight mg, and another force will be tension along the string, and that tension along the string, that is directed towards the center. That means you can say that these two forces that will act, and resultant of these two forces, that will be equal, that will provide the necessary centripetal force for the vertical circular motion. See now here, at upper, as the motion is non-uniform, what happens when the motion is non-uniform? Then at that time, the resultant of these two forces, they are not directed toward the center except at uppermost and lowermost positions. There, the resultant is tangential to the circular path, and it results to change the speed. Now here, at uppermost point A, suppose here the forces acting are its weight mg, that acts in the downward direction, and TA is also in the downward direction. This is the center point O. Now here, this resultant of these two forces provides the necessary centripetal force for vertical circular motion. If you can say that VA be the speed or velocity at this point A, here, then you can say that now here, with the help of this, we can write mg plus TA is equal to mva square upon r, when the particle or the object is at the uppermost point A. We can write mg plus TA is equal to mva square upon r, where r be the radius of the vertical circle, which is the length of the string. Here you can say that at the topmost point, at uppermost point, the minimum possible speed should be there, so that the string becomes slacks and tension vanishes. That means you can say that TA is equal to 0. And in this case, when TA is equal to 0, then you can write mg is equal to mva square upon r. That is, va is equal to va square is equal to rg. That means va is equal to under root rg. This is the minimum speed at the topmost point, where V is equal to under root Rg, where R is the radius or the length of that string, and G with the acceleration due to gravity here. Velocity at the uppermost point, it will be equal to under root Rg. That means you can say that at topmost point, in order to perform the vertical circular motion, the velocity should be under root of Rg. Now here, as you can say that, in order to, we are going to say now velocity at the bottom point here. As you know that Vb be the velocity at this point, you can see it will be equal to Vb. Here in this case, tension that is directed Tb, that is directed towards the center, and the weight mg that acts in the downward direction. That means these two forces are in opposite directions, and resultant of these two forces that decides the necessary centripetal force for vertical circular motion. And these two forces that you can write with the help of this diagram, that is mg minus Tb is equal to mvb square upon r, where vb be the velocity or the speed at point B, that we can write mg minus Tb. Tb minus mg is equal to mvb square upon r. We can write this will be tension Tb minus mg is equal to mvb square upon r. Remember these two equations, that is equation number 1 and equation number 2. That two equations, from that we want to find out Tb minus Ta. Before that, we are going to see now here, while coming down from uppermost point, this A, to the lowermost point B, the resultant displacement is equal to 2r. At that time, here the gravitational potential energy, decrease in gravitational potential energy is used to increase the change in kinetic energy, and that you can write it as here mg, potential energy is equal to, you know that mgh, and h will be equal to here 2r. That means mg into 2r. This is the decrease in potential energy which is used to convert the change in kinetic energy, and that will be equal to 1/2 m vb square minus 1/2 m va square. Here, if you take out m common, then you get mg into 2r is equal to 1/2 m vb square minus va square. Gets cancelled, then you can write vb square minus va square is equal to 4rg. vb square minus va square is equal to 4rg. Here, Va is equal to, as you know that Va is equal to under root Rg, then you can write Vb square is equal to 4Rg plus Va square, and that will be equal to root Rg, and therefore 4Rg plus Rg. That means Vb square is equal to 5Rg, that is Vb is equal to under root 5Rg. That means here the minimum speed will be Rg, here minimum root Rg, and it will be minimum 5Rg. This is the minimum, this is the speed at the bottom position. Lowest speed Vb is equal to under root 5Rg. You have to remember this. You have to remember the velocities at different points, that is at uppermost point, at lowermost point, at horizontal position. We have found out the velocity at topmost will be equal to under root Rg, at lowest position or at bottom is equal to under root 5Rg. Now, with the help of the equation, so this is your equation 1, and Tb minus mg, this is your equation 2. With the help of that two equations, we have to find out now the difference between the tensions at lowest position and at top position. So here, this you have to remember. Now here, subtract this equation 1 from equation 2. Then we can write Tb minus mg is equal to m vb square upon r minus mg minus this. Sorry, we can write Tb minus mg minus Ta is equal to m vb square upon r minus m va square upon r. then you get it will be TB minus TA minus 2 mg is equal to, what happens if we take out m by r common, then it will be equal to m by r Vb square minus Va square. And we have found out what is Vb square minus Va square. That will be equal to 4Rg. That means Tb minus Ta minus 2mg is equal to m by r into Vb square minus Va square. It will be 4Rg. That is Tb minus Ta is equal to RR gets cancelled, 4mg plus 2mg. That means it will be equal to 6mg. This is the difference between the tensions at lowest and uppermost, or at the lowest and top point. That is Tb minus Ta is equal to 6mg. Question can be asked, that is, find out the difference between the tensions at lowest and uppermost point, or prove that Tb minus Ta is equal to 6 mg. This we have to prove. Now we have seen the velocity at lowest position, velocity at upper position. Then we are going to find out expression for velocity at the horizontal position. See here at horizontal position, that means again here with the help of this diagram, this is point A, this is B, here C, and here it is D. Here tension Ta, tension Tb, mg, here mg. Now here at horizontal position, only the forces acting towards the center, you can say it will be equal to Tc, and here you can say it will be equal to Td, and the weight mg is perpendicular to this. That is here at horizontal position, the tension, that is Td and Tc, they are directed toward the center, and mg is perpendicular to that tension. Here that tension that is directed toward the center, that only necessary for the centripetal force to produce the vertical circular motion, that decides the velocity, change in velocity, and mg that decides the change in here this tension that decides, you can say it will be equal to at this direction of velocity, and weight mg is used to change the speed. Then we are going to find out the velocity at the horizontal position, that means Vc and Vd. Now we are going to see here. As you know that at topmost position, Ta, that is mg plus Ta is equal to m Va square upon r. As we have seen that at the horizontal position, only this force, that is tensions, decide the centripetal force. Therefore, Tc is equal to mvc square upon r. These two equations. Suppose this is your equation 1 and this is your equation 2. Now here we want to find out an expression for velocity at this point. Then at that time you can write it will be equal to, if we divide this equation 1 from equation 2, then you can write Tc minus mg minus Ta is equal to mvc square upon r minus mva square upon r. That means it will be equal to Tc minus Ta is minus mg is equal to m by r into vc square minus va square. That is Tc minus Ta is equal to m by r into vc square minus va square plus mg. Here Tc minus Ta is equal to m by r into vc square minus va square and plus mg. This will be this equation. Now we want to find the value of Vc and Vd. Here for that purpose, as you know that when the object comes from point A to C or from A to D, then decreasing potential energy, that is the resultant displacement, will be equal to R. Then in this case, decreasing potential energy will be equal to mg into R is equal to the change in potential energy 1/2 mvc square minus 1/2 m va square. This equation we can write. that is mg into r is equal to 1/2 m vc square minus va square. That is mm gets cancelled, that is vc square minus va square is equal to, you can write it will be equal to 2g. vc square minus va square is equal to 2gr, and this you can substitute here. Tc minus ta is equal to m by r into vc square minus va square, and that will be equal to 2rg plus mg. Here rr gets cancelled, that means you can write it will be equal to tc here with the help of this vc square minus va square is equal to 2rg. After this we have said, then we are going to find out tc minus ta is equal to 2mg plus mg. That means tc minus ta is equal to 3mg. This 2mg plus mg, that means tc minus ta is equal to 3mg. This is the tension at the difference between the tensions at uppermost point and at horizontal position. That is C again here. In order to find out the velocities at point C, and we want to find velocity at this point here, you can see VC we want to find here. Vc square minus va square is equal to 2rg. As you know that vc square is equal to 2rg plus va square, and you know that what is va? Under root rg. That means vc is equal to under root 3rg. vc is equal to under root 3rg, because here, as you know that since va is equal to under root rg, that we have proved. That is vc square minus va square is equal to 2rg, therefore vc square is equal to 2rg plus va square. Va is equal to root rg, therefore vc is equal to 3rg. This is the velocity at the horizontal position. That means vc is equal to vd is equal to root 3rg. In this way, we have found out the velocities at the horizontal position, that is equal to under root 3rg, and difference between the tensions at the topmost position and at horizontal position, that means tc minus ta is equal to 3mg. This we have proved. These two expressions you have to remember how to find now velocities at different positions. That is velocity at topmost position, that means va is equal to under root rg. At lowest position, velocity will be equal to under root 5rg, and at this position velocity will be equal to under root 3rg. This we have to remember. In order to prove this equation, you have to remember that, or prove that how we at topmost position velocity should be under root rg, at bottom it will be under root 5rg, and at the horizontal position it will be 3rg. This velocity changes, and we have found out difference between the tensions at lowest and at topmost position. Tb minus Ta is equal to 6mg, and we have found out Tc minus Ta is equal to 3mg. That is half of that we have proved, because first will be resultant displacement will be 2r, and in second case from top to horizontal resultant displacement will be r. In that case, the gravitational potential energy, decrease in gravitational potential energy is used to increase the change in kinetic energy. This is related to vertical circular motion. That is, if the velocities at the top position, at bottom position, and at horizontal position should be root rg, root 5rg, and root 3rg, then only vertical circular motion is possible here. Then we are going to see the next topic. That is here, instead of this string, if there will be the rod, then what happens? That case we are going to see now. Here, if we consider a rod having mass m, that rod, a bob having mass m, that is tied to a rod and whirled in a vertical circle, then it performs the vertical circular motion. The only difference is that in case of string, the string and rod is that string requires a tension at every positions. Even at the foremost position, there should be the minimum possible speed should be there in order to produce the vertical circular motion. But as the rod is rigid, there is a possibility of velocity will be 0 at the topmost position. That means in case of a rod, the velocity at the topmost position can also be equal to 0. That is VA is equal to 0. Then here we are going to find out now the different expressions that are related to a rod here. First of all, we want to find the velocity at the lowest position in case of a rod here. As you know that velocity at, as we have seen, velocity at the topmost position, that will be equal to 0 at lowest position, and you know that mg plus ta is equal to mva square upon r. This equation we have seen. tb minus mg is equal to mvb square upon r. This equation we have seen. Now, if we subtract equation 1 from 2, then Tp minus mg minus ta is equal to mvb square upon r minus mva square upon r. That means Tb minus Ta minus 2mg is equal to mvb square upon r. Here Vb is equal to, as you can say, Va is equal to 0. In this case, as we have seen that velocity will be 0 at this position, we can find as Va is equal to 0, then our equation will be equal to, first we have seen this, Ta is equal to minus mg also. Here in this case we have to see here, first of all we have to see here, if the rod is rigid, then we have seen that Va is equal to 0. If Va is equal to 0, mg plus Va is equal to mva square upon r. As Va is equal to 0, we can write it as mg, Va is 0, that means it will be equal to mg plus Ta is equal to mg plus Ta is equal to 0. That means Ta is equal to minus mg. Only Ta is equal to minus mg. Tp minus mg is equal to mvb square upon r. This is our equation. If we subtract this first equation from this equation, then it will be Tb minus mg is equal minus, here again, minus mg, Tb minus mg minus Ta. That will be equal to mvb square upon r. Plus that it will be equal to mg. Before deriving this, we are going to see here as Ta, you have to remember this. Tb, Ta is equal to minus mg and Tb minus mg, and that will be equal to mvb square upon r. These equations you have to remember. We want to find the velocity at bottom and at top position. That means Vb minus Va. We want to find at that time, as we have seen that the decrease mg into 2r is equal to 1/2 m Vb square minus 1/2 m Va square. That means mg into 2r is equal to 1/2 m. Here 1/2 m Vb square. Mm gets cancelled. Since here Va is equal to 0, then you get Vb square is equal to 4rg. That means Vb is equal to under root 4rg, or it will be equal to 2 root of 2rg. This is the velocity at lowest position. At lowest position, velocity V minimum, and that will be equal to under root 4rg. Velocity at topmost position will be 0. At lowest position, it will be equal to 4rg. Then we have to see velocity at the horizontal position. Velocity, in order to find out the velocity at horizontal position, here, as you know that, in order to goes the particle from top to horizontal, then it will be mgr is equal to 1/2 m Vc square minus 1/2 m Va square, and this will be equal to mg into r is equal to 1/2 m. Since Vc is equal to 0, you can say it will be equal to 1/2 m. This term will be 0. 1/2 m Vc square, mm gets cancelled. That means Vc square is equal to 2rg. That is Vc is equal to under root 2rg. That is Vc is equal to Vd is equal to under root 2rg. That is the velocity at the horizontal position. That means velocity at topmost position will be 0. At bottom position, velocity will be equal to root 4rg, and at horizontal position, Vc is equal to Vd is equal to under root 2rg. These are the velocities. At topmost position, velocity is 0. Vb is equal to under root 4rg, and at horizontal position, Vc is equal to Vd, and that will be equal to under root 2rg. These are the velocities at the top, bottom, and at horizontal position. If the rod is built in a vertical circle, then these are the different velocities. These expressions are not given in your book, but you have to remember this. You have to prove like this. Now here you want to find the tensions, difference between the tension. How here again Tb minus Ta is also equal to 6 mg. In this case also Tb minus Ta, that is here, as you know that Tb minus mg is equal to mvb square upon r, and mg plus Ta is equal to mva square upon r, but Va is equal to 0. Therefore mg plus Ta is equal to 0. That is Ta is equal to minus mg. Now what happens? Subtracting here, Tb minus mg minus Ta is equal to here mvb square upon r. You can write it will be equal to mvb square upon r first. And this will be equal to T is equal to mg minus minus. If we subtract this equation Ta from this equation, that is, suppose this is equation 1 and this is equation 2, then minus, it will be equal to Tb minus T minus minus. Here you can write Tb minus Ta is equal to mvb square. Vb, that is what we have seen, it will be 4rg power minus minus plus mg, and this mg will be here. R gets cancelled. Then again Tb minus T is equal to mm R gets cancelled. That means it will be 4mg plus 2mg. Again it will be equal to 6mg. This is the difference in tensions at lowest time and at top position. Tb minus mg is equal to mvb square upon r. Mg plus Ta is equal to mva square upon r. These equations you know, but Va is equal to 0. Therefore Ta is equal to minus mg. If you subtract equation 2 from 1, then Tb minus T mg minus Ta is equal to mvb square upon r minus minus mg. Vb, you know, it will be equal to under root 4rg. Therefore Tb minus Ta, this will be equal to 4mg. This m into 4rg by r plus mg. This mg will be here plus, that means Tb minus Ta is equal to 4mg plus 2mg. That means it will be equal to 6mg. All this is related to rod, that is like string. We have seen the expressions in case of a rod also. If that rod is rigid, how the velocities will be different at different point. Instead of string, we have taken the rod, and we have found out the difference in tensions, and that will be equal to Tb minus Ta is equal to also 6mg. Then we are going to see what happens in the expression in case of if the vehicle is moving along a convex surface. This surface is like this. If the vehicle is at the top of the surface, then in this case, this is the center of this circular road. Here vehicle is at the top. Forces acting on this vehicle are the normal reaction N and its weight mg. These two forces, they are in vertical line, but they are opposite. This is the radius. Here you can say that here. When the vehicle is moving at the top, its velocity, you can see it will be equal to v. Now these two forces that decides the resultant force, and that resultant force provides the necessary centripetal force. And therefore, if v be the speed of the vehicle, then you can write n minus mg is equal to mv square upon r. N is the normal reaction that indicates, that is, n is an indication of the point of contact on the road, convex road. Here, if n velocity increases, n goes on decreasing. Here, if only for the contact, in order to maintain the contact, n is equal to 0, then you can say that mg is equal to mv square upon r. That means v square is equal to rg. That means v is equal to under root rg. That is velocity at the topmost point, and it should be equal to under root rg. This equation you can write, it will be equal to not n minus mg. This will be mg weight, that is subtracted. mg minus n is equal to mv square upon r. See here again, what happens if the vehicle is moving along the top of convex bridge? Then the vehicle is at the top. At that time, the forces acting on that vehicle are normal reaction, and that acts in the upward direction, weight of that vehicle that acts in the downward direction. V with the speed of that vehicle, C with the center, R with the radius. Then you know that these two forces, they are in the vertical line. These two forces provide the necessary centripetal force. Then mg minus n is equal to mv square upon r. Here, n is an indication of point of contact. If n velocity increases, n goes on decreasing. If in order to maintain the contact only here, if n is equal to 0, then mg is equal to mv square upon r, that is v square is equal to rg, that means v is equal to under root rg. This is the velocity of the vehicle at the top when the bridge is convex. This equation is very important for your CET questions as well as in order to solve the numericals. This also you have to remember. This is one of the application of vertical circular motion. And another application of vertical circular motion is the sphere of death, mrutyugol. That example or that you have seen in the circus, how that two-wheeler that performs the horizontal circle in a vertical circle that you have seen. That is one of the application of this vertical circular motion. These applications of vertical circular motion we have seen. Then in the next session we are going to see the moment of inertia.